Today we're going to talk about angles of elevation and depression, which is section 2.4 in your trig. Your objective will be to identify and construct angles of elevation and depression and be able to identify those when you solve word problems. First, we must understand the basic definition of angles of elevation and depression. It really comes from what's called a line of sight. So let's say you're looking straight ahead at something. This is a horizontal line that is called your line of sight. The angle of elevation and depression actually come from this horizontal line, depending if you're looking up at something or if you're looking down. Let's say you're looking up at the sun. From that horizontal line of sight up to the sun, just like we've talked about before with initial side and terminal side, you're creating an angle from the initial side of line of sight to the terminal side, which is now called an angle of elevation. So if you're looking at something down, that's called an angle of depression. Let's say you're looking down at somebody's house. From this initial line of sight, looking down to that house, this new angle that you formed is called the angle of depression, which kind of makes sense. It's easy to remember elevation and depress. So when they talk about angle of elevation and depression, you're always referring back to the horizontal line of sight. So let's look at a problem and see what they're asking us to do. Angle of elevation from the boat to the top of the lighthouse. So they're asking you to create an angle of elevation from the boat to the top of the lighthouse. So we're here at the boat. If you notice, they have drawn out your horizontal line of sight for you. Someone's on the boat and they're looking straight ahead. That's considered their line of sight. Well, now if you look at the top of the lighthouse, what you do is draw a line to the top of the lighthouse. What you created now is this angle, which is considered your angle of elevation. So remember, angle of elevation is from your horizontal line of sight to looking something up at something creates an angle of elevation. How about an angle of depression? Now, you still have this horizontal line of sight. So let's say you're the person that's in the lighthouse and you're looking down at the boat. From this horizontal line of sight down to the boat, you created now what's called an angle of depression. Here's a question. What do you notice about the angle of elevation and the angle of depression? So we said if we're at the top of the lighthouse, this would be considered the angle of depression. If we're in the boat actually looking up at the lighthouse, this is called the angle of elevation. See if you can remember from geometry what theorem that is for this angle and this angle. Do you remember what that is? Remember, these are called alternate interior angles. That's going to be important because sometimes you'll be given one or the other, either angle of depression or angle of elevation. And you'll be able to use that alternate interior angles because you know that this measure is the same as what this measure is. So that'll help you in solving your angles depending on what kind of problem you're given. Let's use this example. A monkey hanging in a tree 68 feet tall spots a banana at 23 degrees angle of depression. What is the direct distance from the monkey to the banana? So your job will be to take the information you just learned, angle of elevation and depression, and use real world problems to try to solve for the right for whatever missing part they're asking for in the right triangle. So let's see what they've given us. They tell us the tree is 68 feet tall. So you know the height of the tree is 68 feet. It says the monkey spots a banana at a 23-degree angle of depression. So you have to think about angle of depression. Well, if this is your monkey and he looks straight across, remember we said this is called his line of sight. So the angle of depression is when the monkey actually looks down at the banana, finds it. Remember, this is called the angle of depression. They tell us in the problem that the angle of depression is 23 degrees. Now they're asking you, what is the direct distance from the monkey to the banana? So they want us to find the direct distance from this monkey to this banana. So you have to remember, what is this called? Well, you know that is your hypotenuse. There's two ways you could think of this. We could draw a right triangle right here, or we could draw a right triangle right here. Whichever way you do it, it shouldn't matter because you now know that the angle of depression, which was 23 degrees, and this angle have the same measures. So however you decide to set it up, it's really your choice, because if this distance, this vertical distance is 68 feet here, well, since these two are parallel lines, here and here, then you know this is 68 feet. So let's see how we would set it up. Let's redraw the right triangle. We said that the height of the tree was 68 feet. The monkey was here, so we said this was his line of sight. They said the angle of depression was 23 degrees. We know that this forms a right angle. Now we could drop a perpendicular here and form a right triangle there. Either way you choose to do it is your choice again. They're asking us what's the distance between the banana and where the monkey was. So they're asking us what is this distance. So we know that's our hypotenuse for either one of our right triangles. Well, if this is 23 degrees, we now know those are alternate inferior angles, so this would be 23 degrees. If this measure is 68 feet, then you know that this measure is 68 feet. So whichever way you decide to set it, whether you use the bottom right triangle or the top, both measures will always be the same because you have the theorem of alternate interior angles. So, from the trigonometry we've already worked with and you've already learned, you know that this angle, this side is 68 feet, the height of the tree is opposite, and you already know this is hypotenuse because it's opposite of your right angle on either one of your triangles. So opposite of hypotenuse is sine. So we would say the sine of 23 degrees is opposite, which is 68, over hypotenuse, which we don't know. So we'll just let that be the letter H. Now what I'd like you to do is to isolate H. So we have the sine of 23 degrees equals 68 over H. Remember we said you could set these up as a proportion and just cross multiply. So you have H times the sine of 23 equals 68 times 1, which is 68. If you divide both sides by the sine of 23, all we'd have to do now is take this information, plug it in our calculators, and it'll tell us what the height is. So let's see, we have 68 divided by the sine of 23. So I'll give you a minute to put that in your calculator. I have the height as 174, and we're going to leave it as 174 feet because our original problem was given as whole feet because the height of the tree was 68 feet. So that should help prepare you before you start your homework on section 2.4. If you have any questions, make sure you email me. Thanks, Dr. Marable.